this is lesson 5. We are identifying proportional and non-proportional relationships in a graph. So far we've looked at tables, and we have talked about when you're trying to decide if a table is proportional, you divide y by x. So y divided by x. And you want to see if the values are the same all the way through the table. If the values end up being the same, your table is proportional and you have a constant of proportionality. If you divide y by x for all the values in your table, and there's a number that is different, or all numbers are different, then you do not have a constant of proportionality. It is not proportional. So I want you to take a minute and I want you to look at this opening exercise about Isaiah. And I want you to do y divided by x and get all of your values. Remember, we practiced putting them out to the side. And then I want you to answer that question. Is the amount of candy bars sold proportional to the money he received? And how do you know? So explain. And remember, we talked about explaining, such as putting K equals in a value, or COP in a value, or even making a sentence that would say each candy bar is whatever number of dollars it is. Or if it's not proportional, just putting not prop, no constant of proportionality. And so I want you to divide the y by x's, see what you get over here, and make your decision. The thing is, I want you to show it to me when you finish. So I want you to actually come to my desk with your paper, and I want to see what you've done. Go ahead and pause your video, work on that opening exercise before you press play again. Okay, now we're going to look at this exploratory challenge from going from a table to a graph. But in order to do that, we've got to talk about some different things in a graph, especially because of the way the year ended for us. So I'm going to zoom in on this a little bit more. I'm also going to see about making this a little thinner so that when I write, it looks better. So the first thing we need to do is understand that this is what we call a coordinate plane. It is where we plot points. Those points are called ordered pairs. And ordered pairs are formatted with parentheses, an x value, comma, and a y value. So just like in a table, x comes first. In your ordered pairs, x is also going to come first, and those will be numbers. So this horizontal at the bottom that you see, this is your x axis, and this is your y. The up and down is your y axis. So you can notice right here, we start with a 0 on x and a 0 on the y. This point right here is called 0, 0, and it is called the origin. What's the word origin mean? Well, it means where something starts. And so we start in that corner. Now, if you look at a complete coordinate plane, it has quadrants. And the base word quad means 4. So in a true coordinate plane, you have 4 quadrants. You have this section, which is noted with a Roman numeral 1. Then you go counterclockwise. So you go this way for number 2, this way for 3, and this way for 4, and you use Roman numerals for those. So this is quadrant 1. And we can simplify that by putting Q1, quadrant 1. So in quadrant 1, all numbers are positive. We've got positive numbers going from 0 to 10, and then we have positive numbers going from 0 to 14 on the y-axis. Now, any good graph needs a title, and so we're going to be doing that as we work on this particular problem. So let's look at our table, because we're going to be transferring our numbers from the table to our graph in just a second. So using the ratio provided, our ratio is 2 to 3. We're going to create a table that shows money received is proportional to the candy bars sold. And then plot the points on your table on the grid. So the first set is we sell 2 candy bars, we make $3. So on this side, we're going to continue to add by 2, and over here we're going to continue to add by 3. So I've got 2, 4, 6, 8. On this side, we're going to add by 3, so 3, 6, 9, 12. All right, we know it's proportional because we created it with a ratio of 3 to 2. We're going to go over to our graph now, and we're going to put these down as points. So let's write them as points first. So this would be X, and this is Y, so these numbers need to come first, and Y's need to come second. So this one would be 2, 3, 4, 6, 6, 9, and 8, 12. Again, these are called ordered pairs. So the X goes horizontal. So the first thing I want to look for is I want to look for the number 2. So I'm going from the origin and I'm going to 2. Okay. The next thing I'm going to look for is a 3. So I'm going to go up because that's the y-axis. So I'm going to go from the 2, I'm going to go up to the 3, and that's where I'm going to put my point. So I'm going to make it nice and big here. Alright, so we got that one done. I'm going to check it off. Now we're going to do 4 and 6. So again, this is the X, this is the Y. So let's go from 0 to 4, and let's find 0. Let's go to 4. And then from 4, we're going to go to 6. So I'm going to go all the way up here to 6, right on that grid, okay? So we're looking at those gray lines. Got that one. Now we're looking for 6 and 9. So across the bottom, find 6 right here, and then go up till you find the 9, which is here, and make yourself a nice dot. Got that one. See if you can do 8 and 12. Check yourself. Did you get the point 8, 12? Okay, so let's make some observations about this. We see some dots. Do we see anything interesting about these dots? Anything at all? Well, I noticed that they tend to form like a line. That's pretty interesting. I wonder what that means. I guess we're going to have to figure that out here in just a minute. Alright, so let's go on to our next problem. Example number 2. Graph the points provided in the table below. Excuse me. And describe the similarities and differences when comparing your graph. Oh, wrong one. Let's go down. Let's hit over. Sorry about that. Let's see, we are not there. Here we go, back to the top. So, characteristics of graphs of proportional relationships. This is where we want to be. Let's look back at our graph we just made, and let's look at some of the things we see. So I told you that it looks like it makes a straight line. It does. What is important to notice is that that straight line starts at 0, because if you don't sell any candy bars, you don't make any money. This would continue to happen, and it would continue to go up. If we had a larger graph, we could continue to plot more points. And in fact, we could continue to look at, easily look at multiples of 2. For example, 14, or 2, let's look at example of 10, and we would see it be up here somewhere. So we could get a price for that. So if this was 10, what would this be? 15. And if we continued to graph our point, we would see that this point would be up here somewhere, where 15 would come across. So 2 things to notice. It starts here. Does anybody remember what that's called? the origin, and it continues in a straight line. So we're going to summarize that finding. So characteristics of graphs that are proportional. We're not dealing with non-proportional right now. We are dealing with proportional. So first thing, it makes a straight line. The second thing, it starts, that straight line starts at the origin. So it makes a straight line, starts at the origin. So we're going to graph these points. These points came from the opening exercise. They were given to us and we talked about those, and you brought that one to me so that I can see your work. So you should already know if it's proportional or not. But let's go ahead and graph these points. So the point here would be 2, 3, 4, 5, 8, 9, and 12, 12. So I'm going to graph 2, 3. So 2, 3. And 4, 5, 8, 9, and 12, 12. So if I continue this line, it doesn't have to be a perfect sketch, but if I continue this line, you see a couple of things. Now we talked about just a second ago in the box, 2 things that have to happen for it to be proportional. One thing is it appears to be on a line. So does this appear to be on a line? Yeah, it appears to be on a line. But the second one, does it go through the origin? Does it go through 0, 0? And the answer for this one is no. Okay, so let's look down here. Example 2. Graph the points provided in the table below. Describe the similarities and the differences when comparing your graph. And so we've already got this one labeled X and Y. So we're going to label our points. Our ordered pairs, if you will. Sometimes they're called points, sometimes you'll see them called ordered pairs or coordinate pairs. All of those are the same thing. So 0, 6. So from 0 to 6. From 3 to 9. Notice there's not a 9 on here, so we have to estimate between the 8 and the 10. A 6 and 12. A 9 and 15. Again, there's not a 15, so we have to estimate between the 14 and 16, and 12 and 18. I'm going to change colors. So looking at this one, similarities with example 1. So what is a similarity of this one? You're right, both of them are a straight line. So similarities means things that are the same. So the same thing, straight line. What else do we see? Anything else? This one appears to be steeper. You see this one is going uphill more than this one is. So that one appears to be steeper. So differences, graph 1 is steeper. So which that just means more uphill than the other. It's closer to the origin, but it's still not through the origin. All right. We're going to go ahead and look at our lesson summary. So when two proportional quantities are graphed on a coordinate planes, they appear to be on a line that passes through the origin. They have to have those two things in order to be proportional. So let's start looking at our problem set. Today we're going to look at our problem set together. Determine whether or not the graphs represent two quantities that are proportional to each other and explain your reasoning. So we said it has to have two things. It has to be a straight line, has to go through the origin. So let's look at A. This is not a multiple choice question. This is 4 separate questions right here. So is this a straight line? Does it go through the origin? So is it proportional? Yes. So I'm just going to write problem. B. Is it a straight line? Yep. Does it go through the origin? Nope. So this is not proportional. We're not starting at that 0 point. C. This one doesn't even have the lines drawn, but let's draw the lines. Is it a straight line or does it have a bend? Has a bend. Does it start at the origin? Yes. Does it satisfy both things that we need it to satisfy? Is it straight and through the origin? No. So the end of that one? Yep. Let's go over here. Create a table and graph for the ratios of 2 to 22, 3 to 15, and 1 to 11. Does the graph show that the two quantities are proportional to each other? Explain why or why not. So you probably noticed right away that 2 of these would have a constant of 11, but this one, not so much. So what do you think is going to happen? Let's go ahead and put our quantities in here, and I'm going to put them in from the least to the greatest based on x. So 1 and 11, 2 and 22, and then 3 and 15. So I know if I was to do y divided by x, I'm not going to get the same result every time. But let's do it by looking at a graph. So we're going to plot these points over here. We have 1 and 11. So 1, have to estimate, there's 11, 2 and 22, and then 3 and 15. Alright, so even if we start at 0, and we go through this one and this one, what do we have to do? Well, we have to come back down. And so it satisfies one thing, and that's that it starts at the origin. But does it make straight line? No. And so the question says, does it show that they're proportional? They're not proportional. And then explain it isn't a straight line. Okay, I'm going to let you finish the rest of the problem set and put those answers onto your assessment online. If you need help, see me.